Hello, everyone. Today we'll be going over number 6 from the CSM mock final worksheet. What number 6 is telling you is that what we want to do is create a left-leaning red-black tree given the following insertion commands where we are inserting the numbers 35, 11, 49, 9, 7, 51, and 50. And what we want to do is we want to just draw out our final red-black tree. But before we get started, I have right here a guide on how to approach this problem. So when we're adding elements and we want to create a red-black tree, what we first want to do is add like you are adding to the binary search tree, but you would add all the nodes with the red link. And this comes from the fact that in a binary search tree, when you're adding nodes into a tree, we have to compare values. For example, if we're inserting a node and it's less than the root value, we move to the left. If it's no, we insert it there, and then vice versa if it was greater than. And then after we've inserted our node into our potential tree, we ask ourselves if it violates any of the rules, where if we have a red link on the right of a node, then we would do the operation where we rotate left on the parent node. If we have two red links in a line, as you see in this diagram, what we want to do is rotate right on the parent node. And if we have two red links in the same layer of a tree, then what we want to do is color flip with the layer above. And what color flipping does is that you're reversing the colors. So in this example, we see there are two red links in a layer. So this would change into black. And then the layer above, it's a black link, and we would change it to a red link. And that's basically the operations in terms of inserting nodes into our potential red-black tree. I'm going to pause the video for like 5 seconds. Hopefully you guys can copy this down on your cheat sheet, and we'll move forward because I'll be using this rule book in terms of how I'm approaching this problem. So I'll pause the video now. Okay, so let's move forward to our problem. In this problem, what we want to do is insert the node 35. Because we have nothing on our tree, 35 would just be black. And obviously there is no nodes there, so we don't connect it with the red link. So I'm just following the rules for adding elements. The next thing that we do is insert 11. So we ask ourselves in the rules book, we ask, okay, is 11 greater than or less than 35? Since 11 is less than 35, we move to the left, and since there's nothing there, we insert the node 11. But we have to connect it with a red link. And then after we've connected it with the red link, we ask ourselves if it violates any of these rules. And then these rules over here, and then notice how it doesn't. So we move on to the next step, which is inserting 49. So when we insert 49, we ask ourselves, okay, 35 is less than 49. There's nothing to the right of 35. Therefore, we insert 49. We connect it with the red link. And then we ask ourselves, okay, does this diagram or potential tree look like any of the three rules? And then you may say, oh, it does. It is the same as rule number 3, where we color flip. And then what ends up happening is that our diagram now changes from two red links in the same layer to black. And since there's nothing on top of 35, it would still represent a black node. And then we move on to the next node, which is inserting 9. And we follow the same binary search tree algorithm where we're inserting a node. What ends up happening is we're inserting 9 to the left of 11, and we connect it with the red link. And we ask ourselves, does it violate any of the rules? It doesn't. So we move forward in this operations of insertions. Notice how it can be a little bit tedious, but with much practice, you guys will be much faster in terms of solving these problems on an exam if this ever shows up. So we move on to the next operation, which is inserting 7. 7 is to the left of 9. We insert it with the red link. And then we ask ourselves if it violates any of the rules. It so happens it does, where it violates number 2. What we want to do is rotate right on the parent node. And you may ask yourselves, what is the parent node? In this case, the parent node is 11. So what we do is we rotate right on 11, and we just follow the diagram over here. We follow the diagram over here. So then let me quickly change this up. And then the follow-up question is, do we still violate any of the rules? And then you notice that it still violates rule because we still have 2 red links in the same layer. And that's rule number 3. So what we do is we color flip on 9. What ends up happening, these 2 links turn black and this turns red. And then we ask ourselves, does it violate any of the rules? And we notice it doesn't. So we can move forward in our insertion process. After that, we insert 51. Using binary search tree algorithm, we notice 51 is to the right of 49. And we connect it with a red link. And then we ask ourselves, does it violate any of the rules? We notice that it does. It violates rule number 1 because we have a red link to the right of the node, which is represented over here. So what we do is we rotate left on the parent node, and the parent node is 49. So when we rotate left, what we get is this. And then we ask ourselves again, does it violate any of the rules? We notice that it doesn't, and we continue the process. I'm going to move a little bit quicker here because I hope that you guys get the idea. But yeah, so what ends up happening is that we have to insert the node 50. We notice that 50 is to the right of 49. We insert with the red link, and then what happens is that it violates rule number 2 because we have a red link to the right of a node. And then what happens is that you rotate left on the parent node, which is 49. You would get 50, and then 49. And then we notice that we have 2 red links in a line. So what ends up happening is that our tree would be shifted as such. And we notice that because we have 2 red links in the same layer over here, we have to color flip on 50 as stated in rule number 3. Color flip. And then when we do this procedure again, we notice we still have 2 red links in the same layer. So we have to color flip again, but on 35. And then looking at this final red-black tree, we notice that it doesn't violate any of the rules as stated, and we have no more insertion operations. And this is your final red-black tree. So that concludes this problem, and thank you.